Students, welcome back to the part 2 of the lecture number 2. So, we have discussed about neurons. Let me just remind you, this is the typical processing element in artificial neural network. So, you have inputs coming from dendrites. The processing is done by the cell body or nucleus. Synaptic links, basically they provide the links, and axon provide the output. That is what we know, right. So, that is the structure which you are using here in case of neural network. So, you are using inputs from the synapses, adding some biases, then putting some weights on each inputs. Remember this, the reason we are putting weights is because we can change or we can actually modify the effect of each of these inputs and then sum it over everything actually and apply activation functions. So, the next we will talk about, there is a single layer, but really we use multi layers and we call them multi-layer perceptrons, not neurons. Neurons are used in the medicine or human biologist. In the artificial neural network we use perceptrons. So, human has unique capability to identify patterns with some accessible information with a very high degree of accuracy. You are taught by your parents that some object is bicycle, some object is a motorcycle. You can see it and detect it. Why? Because it has been taught by your parents that bicycle has such a kind of shapes, such a kind of features, vis-a-vis motorcycle has other kind of features. So, that is why we can detect it with a very high degree of accuracy. Can the neurons do that in artificial neural network or not? We will see that. So, whenever that is what I say. So, artificial neural networks are computation system that intend to imitate this human learning capabilities. But is it so easy? Because human brain is a very complex architecture. So, therefore, we will try to mimic as much as possible that architecture. Hence, Frank Rosenblatt from Cornell University, USA, first time started the concept of perceptron. Perceptron is simple binary classification algorithm, 0 and 1 binary. Something which is not true is called 0, something which is true is called 1. So, unlike any other classification algorithms which you may have read from the classifications algorithms, perceptron is modeled using a concept known as a essential unit of a human brain, like a neuron, correct. And neuron has these uncanny abilities to learn and solve problems, that is why. So, it can take few inputs, each of has the weights to signify how important these are, that is why weights are there. Weights are basically used to signify how important a particular variable is and generate the output in terms of a 0 and 1, switch on and switch off. So, whenever we combined with other perceptrons, it forms the ANN, artificial neural network. So, any neural network can in principle answer any questions, how difficult it is using enough training data and computational power. That is why, because it has perceptrons which has abilities to mimic human brain. So, in a multi-layer perceptrons is nothing but a network formed by teaming up many perceptrons with additional ones can be stacked in different layers to solve the complex problems. So, you understand, basically it is nothing but a network which formed by various number of perceptrons layer wise, stacks in different layers. I will show you some pictures next slide. So, each perceptron in the first layer, that is to the left, on the left is basically called input layer, that sends output to the perceptron in the second layer or what is called a hidden layer, and all the perceptron in the second layer sends output to the first layer or the layer to the next one, and it goes on. Okay. Let us go back to that. Here you see here. So, these are the input layers, it receives the signals, transfers signal to the second layer, it transfers signal to the third layer. Here also shown here, right. This is the multiple layers you can see, input, this is this second layer, this is the third layer. Okay. That is what is the multi-layer system is. Okay. So, each layer can have a large number of perceptrons, as many as possible. You can put thousands of perceptrons depending on number of variables, and there can be multiple layers like thousands of layers possible. So, multi-layer perceptrons can quickly form a complex system. Okay. That is what we are talking about it, very complex system it can form. So, in a 3-layer MLP, just like the diagram I have shown you, it is called a non-deep or shallow network. 3-layer. 3-layer means one input, then first layer, this is also called hidden layer, and then output. This is basically called shallow or non-deep. Right. So, deep neural network is basically given rise to deep learning process. So, therefore, you must know what is non-deep versus deep. In a non-deep, you have only 3 layers: input layer, first hidden layer, and output layer. That is it. But in a MLP, you will have at least 4 layers or more. That is what is called a deep neural network, and some people call DNN, and that is from that words only deep learning concepts came into picture. So, the difference between an MLP and a neural network is that in classical perceptrons, decision functions are step functions and output is a binary 0 or 1. So, what does it mean? Decision function means what? The activation functions. They are what is, that is what is creating, making a decision, right. So, that is basically a step function. We will show you how this step function is, and output is binary 0 or 1. In neural networks that evolve from MLPs, other activation function can also be used. So, you understand, right? MLPs are specific form of neural networks, which has decision functions like a step functions, and output is a binary. But it may not be the case for all. You can have other activation functions, or you can have outputs which can be real values. It can be between 0 and 1, it can be between -1 and 1. There are many real numbers present, right. So, that gives you many advantage in terms of probability based predictions or classification of item into multiple levels. Okay. So, that is the main difference between a perceptron based model and neural network. Perceptrons only takes binary data, right. Go back, it only takes binary things, right. You can see that it is a binary classification algorithm, 0 and 1, okay, outputs, and perceptrons also have a step function, which is basically a decision function, right. On the other, neural networks may not have only step function as the decision activation functions. It can have also output values in real numbers between 0 and 1 or -1 or 1. Okay. So, this is the main difference between that. So, why you change it? Because this allows you to use the concept of probability based predictions like Bayesian classification algorithms, or many other probability based algorithms can be used for classification items of different types. So, how does it work? Let us talk about it. It takes input, multiply them with some weights, I already told you, and computes the sum. Then add the bias or the number, multiply this whole thing by weights, feeds the sum to activation function, and that is the result of the perceptron output. Let us talk about it. So, what is a common transfer function and activation function? Okay. We call also activation function, remember that both the names are used, activation or transfer functions. This is applied after it sum it over, biases are added, everything. So, very simple one is a sigmoid function, which is nothing but this one, this kind of function. So, many people like this 1 by 1 plus exponential minus x e to the power minus x. Okay. You can also use a linear function like this. You can also use ReLU function which is like this. Okay. So, ReLU function is 0 for x less than 0, negative values, and it is equal to x for x more than 0. Okay. So, that is what is the ReLU function is. So, hence there are different kinds of transfer function which can be used. The most easiest one is obviously sigmoid one, and I will tell you why. Because exponential functions e to the power x, e to the power minus x, how does it looks like 1 minus x by factorial 1 plus x square by factorial 2 minus x cube by factorial 3 plus x to the power 4 by factorial 4 minus it goes on, right. Since it is a highly nonlinear function, it has all powers of x, whatever way you can terminate, whichever way, and that is why it is used. Please keep in mind that. And also if you look at carefully, the function shapes looks like this. It is 0. So, when its input is 0, it has certain finite values, e to the power 0 is 0. So, it is basically become 1 by 2 half, and then it goes increases, right. Linear is easy to understand. There are many more functions which we will discuss as the things goes on. You can have different kinds of networks, multiple neurons, multiple inputs and single layer. You have multiple inputs. These are the inputs x1, x2, x3, x4, and only single layer. You can see this is single layer, and this is input. Whatever happens, you get output. You can have multiple inputs and multiple layers. We already discussed about it. You can see multiple inputs, then you have a hidden layer. Okay. So, this is also called hidden. Hidden is very common term used in machine learning or deep learning. How many hidden layers? And third layer is output. As we told you that when there are more than 3 layers, then only we call it deep neural networks. You can also have a recurrent network. What is that? So, what you see here, each of these inputs are connected with the second layer, okay, crisscross. Like this one is connected with this, also with this, also with this, also with this. Same thing is true for each. So, this is called recurrent network. It can go back and forth. Okay. So, one of the ways of making it recurrent is to provide the feedback, right. You can see whatever output is coming here, it is placed as a feedback, okay, in each of the cases. So, that is why there is something called a recurrent neural network, RNN. They use the concept of recurrent. Please remember that recurrent network will use feedback loops. So, what is the learning techniques? In case of supervised learning techniques, inputs are received from the environment, fed to the actual system, and you get some expected output. Then again this is also fed to the neural networks, you got actual output, calculate the error between these two and train the model to reduce the error. That is how that learning is done, very standard one. Okay. From the actual system, how the model is varying, that is what provides you error. From the error you can do that. So, let us talk about a little bit more on the multilayer perceptrons. So, as you see, there are many inputs here, xn, and the first hidden layer you can see hidden word always, second hidden layer and output layer. So, it has basically 4 layers, right. That is the minimum layers required to make a deep neural network. Remember this, minimum number of neural networks. So, the first hidden layer you can see these connections are made, same connections are made here the second layer also, and finally you get output layer, and this output is sent to the next neuron. Okay. That is what it is done. So, hence we can build this kind of complex architectural different layers wise. Well, how do you correct the errors? That is why the backpropagation is used. So, as you know, we will talk about backpropagation soon. So, you have these signals coming, function signals coming, and the output, from the output, the whatever error happens, you can feed through and bring back to that. So, let me just go back one step forward and explain to it in detailed manner, so that you understand. So, you see here you have inputs x1, x2, xn and biases. These are the weights, right. Weights are variable, remember this. Weights you can change. You sum it over, apply the activation functions, get the output. Compare whether output is as per required value or not. If the output is not expected what is needed to be, there will be error. So, this error then allows you to go back and change the weights or change the bias also. So, the moment you change all these things, again the summation will change, again I apply the activation functions and get the output again, compare with the actual thing or real value. So, this is called a backpropagation. You go back and forth, right. So, that is why it is widely used in the systems, and this is what is called signal flow backpropagation of errors. Okay, you can see that how error signal follows that. So, we will talk about examples later, maybe not now. Let us first talk about different steps first. So, in the step 1, it takes the input, multiply with weights and also biases and compute their sums. Why? Weights allow the perceptron to evaluate the relative importance of each of these variables, because you have variables like x1, x2, x3, x4, xn, right. I do not know which of these variables are more important than the others a priori, because these are all affecting your results. So, that is why we put different weights, that weights will give you relative importance of each of these variables. Neural network algorithm learns by discovering better and better weights result in a more accurate system. That means, these weights are basically changeable. These weights are changeable, and this weights actually allows you to calculate our accurate predictions. There are many algorithms which we will discuss how to fine tune the weights. Most common one is basically, I talked about it, backpropagation. The steps 2, you add the bias factors. So, I think I told you wrong, here you do not add bias in step 1, you simply multiply the values, input values with weights and compute their sums. Steps 2, you add the bias. Okay. So, here you have basically this one x1, w1, x2, w2, x3, w3, it goes on till xn, wn, and then you add the bias. These are technical steps. Why? Because it is possible to move the activation function curves up and down, left and right on the number graph. That is why the bias is used. Okay. Basically, what the bias does is, if there is any error in terms of the inputs, it can take care of. But as you see, in technical steps, it is possible to move these activation functions curve up and down, because activation functions, as I told you, very simple activation function is sigmoid. This function can go up and down depending on the values of the bias. So, that means it allows you to fine tune numerical output of the perceptrons. That is what is the step 2, the bias does. Bias allows you to fine tune the numerical output of the perceptrons. Step 3 is what is activation functions. So, you added everything, right, you added this, multiplied, added and added bias. Now, you apply these activation functions onto this. Activation function basically maps the input values to the required output values. So, for example, if input values could be between 1 and 100, output can be 0 and 1. So, activation function also helps perceptron to learn which part of the multiplier perceptron is playing more important role. That is what it learns. Okay. So, that is why activation functions play a very key role in terms of converting these input values to the output. Certain properties of the activation function, especially nonlinear nature, makes these neural networks to train complex problems. That is why, because activation function can be as complex as possible. I told you simplest activation function is linear, right. This is what the simplest one, or ReLU, correct. ReLU is like this, I told you. The complex one is very complex, sigmoid is one such, tan H is another such. There are many such complex functions exist. Step 4 is the perception output. Is a classification decision basically. In a multi-layered systems, output of one layer perceptance is the input of the next layer. That is what happens. So, output of the final perceptance is called the output layer or the final prediction of the perceptance. So, depending on how complex the problem is, you can actually put many layers, and each of the layers can calculate these perceptance values. Okay. So, there are 4 steps, you have to understand that. Now, how do you calculate the errors? Let us spend some time here, so that you understand. That is why I use the backpropagation algorithm. This allows you to perform this backward pass. Backward pass means whatever output has come, that can be compared to the actual values, and error calculated by that way can be used for fine tune the values of the weights and the biases. It is an algorithm commonly used to train the neural networks. It performs iterative backward passes many times, go back and forth, that attempts to minimize the loss. Remember, error in machine learning is always called as a loss. We look, loss is what is used more widely. That is nothing but difference between the known correct predictions and actual model predictions. With each backward pass, weights move towards an optimum values. The values of W1, W2, W3, W5, it moves to the optimum values that minimizes the loss functions and results in the most accurate predictions. I will not say most accurate, as accurate as possible. When the neural network is initialized, weights are set to certain values, individual elements, okay, whatever, and then these inputs are loaded, they pass through this networks of neuron, and it gives you output whatever given, and this backpropagation helps you adjust these weights. So, in a nutshell, those of you who know machine learning, it is basically nothing but a hyperparameter tuning kind of concepts. Okay, so, you go back and tune the values of the W's or weights, so that you get a better idea how these weights can be fine tuned. And with this, I would like to stop here and thank you for your patience. So, we will build on more on this in the next lecture.